These are notes 6.2. We're going to start off with talking about inverse functions. Inverse functions is our topic for today. And what does it mean for two functions to be an inverse of one another? Okay. If they are inverses of one another, say function f and function g, we can say this. If g is the inverse of f, then we can put that up here for you. If g is the inverse of f, then we can say that point AB on the f curve, or in the f function, will be point BA on or in the g function. And we have a notation for the inverse. If g is the inverse of f, then we say g is equal to f with a little -1 that appears to be an exponent, but this is not an exponent. Okay? Don't get this confused with this. When we have f of x and we do this, then it's 1 over f of x. But in our case here, this is not equal to 1 over x. This is that inverse. Okay. So, on our first one, we're going to decide whether f and g are inverses, and we have a table of values that we're going to use to check that. Okay. So, I'm just going to start here with our first x value and y value. Okay. So based upon this, if I substitute in 0 for x in the f of x function, what I'm going to get out is 4. So in other words, we have the point 0, 4. Let's compare that to our g function. The input to our g function would be this output 4. Remember what we said up here. If AB works on f, then BA has to work on g. So let's take a look here. X equals 4. What do we get from g? We get 0. So does that one work for us? Yeah. We get the point 4, 0 in the g function. Let's try our next value. We're going to do this for each one of these x values in the table. We're going to try f of 1, f of 2, f of 3, and f of 4. We're going to check all of these. Okay? So when we get, we get 1 when we substitute 1 in for x in the f of x function. So this is the point 1, 1. And I'm just going to go ahead and fill all this in and then just check against our g function, just because it's kind of handy here. We know this is going to be 3, the point 2, 3, and 0 and 2. So these would be the points 3, 0, and 4, 2. We're going to check each one of those with our g function, because what we want to get here is 1, 1, and the next one would be 3, 2, followed by 0, 3, and then 2, 4. If any of these don't work out, then these two functions are not an inverse. So let's go ahead and check g of 1. We substitute in 1, look at the g row, and indeed we get 1. Let's substitute in. This time we're substituting in 3. Remember, we're flipping these two guys around, and hopefully we get 2. So 3, and indeed we get 2. And I think I skipped one, didn't I? No, I didn't. Next one is we're going to substitute in 0 in the g function. 0, our output is 3. That matches 0, 3 from the 3, 0. And our last one, fingers crossed, we're going to substitute in 2 in the g function, and our output is 4. So yes, indeed, these are inverses. Gotta love it. Let's take a look at our next table. And in this one, again, we have to make sure we're reading off these correctly. We're going to read the f function, its values, and our g function's values, and just compare those. Okay. So let's take a look first at the f function. We have f of -10, and we get 0, so we have the point -10, 0. And again, I'm just going to do all of these just to have them here and do a quick check with those, because if we only check some of these, then we may miss something that's wrong in here. Because if there's just one point that doesn't work, then these are not inverses. And then our last one, so I've put in each one of these 5 x values and just translated those from the table into a set of points, 10, 5. And if this works out, I should get the inverses of each one of these. So in the first one, I'm going to substitute in 0, then I'm going to substitute in 10, then the next one I'll substitute in 5, then substitute in -10, then substitute in 5. And all I did was take each one of these values that are here and use those for the inputs in the g function. The results better be the same outputs. So let's check this. When I substitute in 0, I'm going to go down to the g row, and we get -10. That one checks out okay. Next, we're checking 10. I'll go to 10 and the G row, and we get -5. Love that. We're rolling. Let's check -5. -5. We get 0. Gotta love it. We're cruising now. -10. And we get a +10. We read that right? -10, 10. We were supposed to get 5. -10 was from the 5. Wah, wah, wah. Is this going to be an inverse? No, not at all. Okay, don't even need to check the last one. If we did check the last one, looks like when we put in 5, well, this one doesn't work either, does it? So all we needed is one of those to be incorrect, and it looks like we can have to say no, these are not inverses. Okay? So inverses from a table, just switching your x and y values, your a's and b's. All right? Let's take a look at the graphs. When we talk about inverses, we also want to take a look at the graphs. Okay? So let's go ahead and plot this these values here, and let's do a quick little check. So I'm just going to go here, and when x equals 0, we're going to go up to 4. That's our first point here. I'm just plotting each one of these points. We go through 1, 1, to the right 1, up 1. We go through 2, 3, to the right 2, up 3. And we go through 3, 0, to the right 3, not up at all. And 4, 2, to the right 4, and up 2. Those are all of these points here. Okay. Now I'm going to go ahead and do the same thing